previous chapter. Remember, it's both of them, but I'm gonna go check the gentleman's homework and then we'll talk about it. There was 4, 5, and then 2, A through C. Good job showing work.
I did my part.
I almost crashed into the camera. 4, 5. Good job showing work. Alright, we'll come back to the balancing ones. Let's do number 4. Alright, Jamie, they kind of, and Quentin, they kind of cheated and they asked me in study hall because they got stuck. Okay, not both of them, but one of them in particular. So it's okay. Alright, so for this one, the extent of carbon dioxide produced in the normal waste product metabolism must be removed from the cabins of space vehicles. That is actually something that they have to do. One technique removes carbon dioxide from the cabin using lithium hydroxide, which reacts as following, and then it gives it to you. What is the mass of carbon dioxide that can remove from the atmosphere by 454 grams of lithium hydroxide? So, since they're working with it, scientists, they can't really measure out in moles that well, so they have to measure it out in grams. So they're saying, okay, if I start off with 454 grams of lithium hydroxide, I need to know how much carbon dioxide I can remove. So sometimes it might help you to write it out like this, so you can see, okay, how much of a substance do I need, or where am I going with this substance? I'm going to shift it over a little bit so you can see more of the board. Alright, now it's asking for this one as well, but it's asking specifically how much mass. Now, if you're finding mass, what units do you have to find it in?
Grams per molar.
Okay, that's molar mass.
Wait, what?
If you're finding it in mass, it's actually grams. So that means you should be finding in grams or kilograms, I guess technically. But okay, how much mass, how much of it will be sucked out of the air if I'm using lithium hydroxide? So you have to use a mole-to-mole ratio, but you're also going to have to use molar mass. So it's kind of like that last thing we talked about yesterday, where you're combining molar mass and mole ratios. You do both at the same time. Alright, I'm starting off with 454 grams of lithium hydroxide. Now I gotta go from grams to moles. So what do I use to go from grams to moles?
Grams mole.
Right? So what goes on the bottom? If this is grams per lithium hydroxide up here, what has to go down here?
Grams per CO2. Or CO.
You're going straight from grams of lithium hydroxide to grams of CO2. Alright, what's the unit? Alright, so what is this exact unit? So grams lithium hydroxide.
So it'd be grams CO2. Right?
You're okay. What is the substance?
Lithium hydroxide.
Alright, so grams lithium hydroxide, what has to go down here to cancel out grams
lithium hydroxide.
There you go. I can't tell if you were just thinking you were dumping the whole substance or if you just weren't saying the name of the substance correctly. Alright, so grams of lithium hydroxide goes down here to get 1 mole of lithium hydroxide. Alright, if it's moles of lithium hydroxide up here, what has to go down here to cancel out? If it's mole lithium hydroxide.
Moles lithium.
Moles of lithium hydroxide. I'm going to have to start squishing stuff together because I'm going to run out. I got to remember to do myself more space. Alright, so mole-to-mole ratio. How many moles of lithium hydroxide are made for every mole of carbon dioxide? You can look at the balance equation for this one. What's the coefficient for lithium hydroxide? Alright.
I actually didn't look at it, remember.
That's good. Alright, how many moles of carbon dioxide in this balance equation? This is not the balance equation.
1.
Good job. Alright, so this is, I'm going to write moles so I won't forget. 1 mole of carbon dioxide. Oh, this is mole of carbon dioxide. What goes down here? Chris.
Carbon dioxide.
Which one?
Carbon dioxide.
Mole or grams?
Mole.
Mole. So 1 mole carbon dioxide will equal how many grams of carbon dioxide?
44.
It sounds like that might be right. Alright, so figuring out molar mass. Now I have to figure out molar mass of lithium hydroxide and molar mass of carbon dioxide. Alright, what's the mass of lithium hydroxide? Hopefully you wrote this down so you can still
Is it
check.
17.008?
That doesn't show.
23.95.
Let me find it. Alright.
23.1?
95.
Oh yeah, I have that.
Alright.
Oh, I added the lithium and the hydroxide again. That's what the 17.008 was. Okay.
Alright.
I have 6.94 plus 17.008. And then
Yeah, not sure what you're doing for that one, but yeah. So
I got it.
Okay. I'm gonna leave it unrounded. So if you round too early, it might mess up your sig fig. So if you round it, that's probably the reason why you want to show me what you did at each step, so that way I can figure out what to do. So if you round it early, your answer will probably still be right, but it could be slightly off. That's gonna want to show me at each and every single step what you did. All right, what do you have for the mole mass of carbon dioxide?
37.92.
Alright, yeah, it's not right for that one.
24.01.
There you go.
Yeah, that's what I had.
Is that really what you have?
No, it's not.
I was gonna say, okay, you don't Okay, so just make sure, it's okay to be wrong, but it's one of those, you wanna slow down and make sure what the proper answer for. Alright, so now you take 454, if it's in the bottom, do you multiply or divide? Divide. And so, if it's in the bottom, do you multiply or divide? Divide. If it's in the top, multiply or divide. You think?
If it's in the top,
Yeah,
multiply.
multiply. I'm leaving off the ones because dividing by 1 or multiplying by 1 doesn't change anything. You can still type it in, it won't affect it. But it's 454 divided by 23.948 divided by 2 times 44.01. Wait, is it? I have to wait. Alright, raise your hand. Okay.
417.165107.
Alright, so we'll just start from there
So
because
it's just 417 though, because we started with 106.
Good job. So you're right, there's just only have 3 to do. But what's your unit since we're doing?
Grams per mole.
Well, I ended up
Grams.
grams because I'm finding specifically what mass. So grams CO2. That is the final answer. Alright, Ethan, did you get that?
Yes. I was making sure I had the right.
I was like,
I forgot
you sound very
gram.
confident, but okay.
I got gram. I forgot to put gram.
Okay, so just remember because we're finding mass, it's got to be in grams or kilograms, but grams. If you're finding the molecular weight, that's whenever it's in atomic mass units because we want to know exactly how much it is. Alright, let's look at number 5 now. So a little bit farther down, but it's the same idea, just practicing with this concept. And it's a good idea because it combines mole ratios and it combines molar mass. So I like these types of problems. Tarnishing of silver is caused by small amounts of hydrogen silver released into the atmosphere by decaying organic material volcanic activity. That really is happening. Hydrogen sulfide's reaction with silver and atmospheric oxygen is, and then gets it to you. How many grams of silver sulfide could be produced from 1.7 grams of hydrogen sulfide if sufficient amounts of the other reactants are present? So it's saying, okay, what if I have 1.75 grams of this substance, how much of silver could I make? Alright, anyone want to give their answer because they think that they are exact and perfect? Okay.
On number 2?
No.
On number 2A?
No, number 5.
Number 5. 0.0138.
We'll talk about it. Okay, so
Well, I
let's
have 51.048, but that's not even close. I don't know.
Alright, so let's talk through how to solve this. Alright,
Nuts.
so what am I starting off with, Ethan? What am I given?
1.70
Alright, and what substance is that?
grams. What was it?
Look at the book. What is it?
Let me get my book out.
I'm gonna go ahead and move down so that way I won't forget.
My answer is the right question.
Camera, move it down.
My answer.
What page? 59?
I believe it's on page 59. Alright, Chris, we'll let you answer. So,
Grams per mole.
nope. So, what substance am I starting with? So, 1.70 grams, what am I starting off with, according to the story poem?
AG silver. AG.
Okay, H2
Yeah.
sulfide, but yeah, so A2S, so 5 is a little
Ah, same.
Nope, H3 is not the same thing.
Just like dihydrogen
Alright,
sulfide.
what am I finding? What am I going to?
What?
What am I finding? What's the problem telling me to find?
How many of that can be produced from sulfur?
Alright, Ethan, are you already there?
59?
59, problem 5 at the bottom.
What was the question?
What am I looking for? So I'm starting off with
How many
100
grams of silver to sulfide?
There you go. So I'm finding grams of silver sulfide. So I'm going from hydrogen sulfide to silver sulfide. So that's where I'm going. Alright, I'm starting off with 100, sorry, I keep saying 100, 1.7 grams of H2S. Now this is grams H2S. What has to go down here?
Grams H2S.
Grams H2S. So my units cancel. Alright, so I'm going to go from grams to mole. So 1 mole of H2S. Sorry, it's getting kind of messy. Alright, according to, so this is moles of H2S. What
Moles
is
of
up here?
H2S.
You gotta make your units match up. Alright, so according to the balanced equation, what is the mole to mole ratio? How many moles of silver are needed? Sorry, moles of silver sulfide. Silver sulfide.
2.
2. So that is, I cannot talk at the same time. So, 2 silver sulfide, how many moles are needed for the H2S?
2.
2. So this is a 2-to-2 ratio for it. Now, if I were to just stop here, they would give me the number of moles, but I have to keep going because it's asking for grams specifically. So, moles, Ag2S, and then I can figure out from that how many grams of H2S that I need. So going from moles to grams. Alright, so I have to figure out molar mass of H2S, and I have to figure out molar mass of Ag2S. So what's the molar mass of hydrogen sulfide first up? Anyone already have that written down?
Wait, what?
What's the molar mass of hydrogen sulfide? So this one,
Hydrogen
H2S.
sulfide. Is it 32?
1.70.
Is it 32.010? Is it 431.6?
Nope.
Is it
How do you get that answer?
64.12?
Alright, H2S. How do I find molar mass of H2S?
There's 2 of them, right?
2 hydrogens, and then how many sulfurs?
1.
Get up. So you add it all up together.
Sulfur is what, 64 or something?
Silver is 32.06.
34.076.
Good job. That's the answer. So 34.076. So it sounds like you might have just went too fast through your
How do
calculation.
you-
So slow down.
How do I what?
Go over that. How we got
Okay, molar mass. So hydrogen weighs how much?
1.008.
How many hydrogens are there?
2, so times 2.
Times 2. How much does sulfur weigh?
34.06. I'm guessing. I'm throwing a number out.
Alright, so close. 32.06.
I was so close. I was a guess.
Alright, so 2 times 1.008
Oh, okay. I
plus.
was wondering how they got it.
What is the 0.007? Alright, so that's where that number comes from. Alright, so molar mass of silver sulfide. So silver, 2 of them, and then get sulfur again.
There's
Sulfide still weighs 32.
silver is hold on.
A big number.
Ag
Ag.
107.3, right?
107.9.
Oh, come on.
How can you see that far?
Some people can.
I have good eyesight.
It's okay. Alright, Chris, did you already figure out the molar mass? It looks like you already figured it out.
For what?
For silver to sulfide.
Sulfide is 32.06. 139.96.
There's 2 silvers.
Alright, 107.9 times 2 equals
Ethan, did you get the answer already?
247.86.
Good job. Is that what you got, Ethan?
Yes.
Okay. Alright. So, that's one. So, for this one now, it's just a plug and solve. So, 1.7 divided by 34.06 times 2 divided by 2. I know they cancel, still do it. And then times 247.86. And that'll give you your final answer.
12.37. In reality, it
12.37. Typing.
Okay, good job. So, I let you round last time, so let's let Ethan on. Alright, Ethan, how many did I start with? How many things?
3.
Alright,
Two.
there's a whole bunch of multiplication and
3. I said 3.
3. There's a whole bunch of multiplication and division, so what does this become?
12.4
Good job, and I'm finding it, and I'm finding mass, so what's the units?
grams.
Yes. Alright, anyone have any questions about how to find this? Anyone have any questions about multiple ratios? Like what if it
Can we
adds,
never do that again?
well you know, you test this tomorrow, so I'm just letting you know. Does anyone have any questions about multiple ratios? Like what if it asks for moles of silver? If it asks just for moles of silver, how would you solve this? What would you do?
Wipe off the far right.
Wait, on the test, when we have to do that, will it give us how much is silver or something like that?
Yeah, so for Jamie and Clinton as well, if you're asked to do something like this, I will tell you how much they all weigh, so that way you do not have to use a periodic table for it. So I will tell you what everything weighs against it. But yeah, so you were saying you wipe off just this?
Yes.
Alright, so what would be the molar ratio if you're going from gram to silver? I actually, the book does not tell you this, so I actually have to start it myself too as well.
Wait, was more to it?
No, I'm just
About to say.
extra.
I was about to say.
Alright, so if make sure I typed it in correctly. Alright, so if you wanted to find how many substances, grams, how much of a mole of silver you would get, how did you figure it out? Or what would you do?
0.05.
Check it one more time.
I did 1.70 divided by 34.076. Now times it by 2, now divided by
Tell me
2.
exactly what you see in your calculator.
Okay, I'm typing 1.70 divided by 34.076 equal sign
Okay.
times 2 divided by 2
Okay.
and get 0.049888485.
Why do you put on the answer? Where did it come from? Okay. Yeah, that, okay, that's answer accurate, but that's not the answer you're saying. So just be careful.
What was I saying?
You were saying point 0.4. That's like, I'm like, okay, he's missing a spot. That's what he's saying. Okay, just be careful. Alright, so 0.04, now give your answer.
0.0498884.
Okay, so yeah, so this would be number of moles, so if I start off with 368, how do I make this 368?
0.050.
That?
Yep.
How many six is this?
Big.
What? I can't hear him.
So wait, would be 0.0451?
Where are you getting 5
Because you have to have 3. And
Okay.
if you round from the 8 to the 9, you can't write 10.
Alright, does this one count as 6 8?
No.
Okay. So what if I write it like that? How many 6 8?
0.0499.
So how many 6 8? There you go. So you're just over analyzing it. But yeah, so for this one you would just round up just the one just round up 1 9 and 1 8 into the 9 and then you're done. Alright, so this would be per mole. Alright, anyone have any questions about how to solve that? I know it's kind of extra. I'm just making sure everyone's covered. Alright, let's go over number 2, A through C for this one to check to make sure. I like these because they also make you check your ions, which is also on your test. So you need to know them. That way you can figure this type of thing out. I won't ask it in this detail, but I'm going to ask you, here's a substance, name a molecule. Or here's a molecule, what's the name for this substance? So you have to go it both ways. Alright, Ethan, give me your balanced equation for A. Just say the whole thing. It's okay.
CaCl plus 2.
Wait, is this your first sentence?
Yes.
Okay, just make sure.
2NH. The balance of balance, right?
Yeah, you can go get me out.
2NH4 CO3 arrow CaCO3 plus 2NH4 Ci.
Okay, Cl, but yes. Alright.
Yes.
Is this exactly what you got?
No.
Okay, what did you have that's different? Because you were super close, you missed out one thing.
CaCl plus NH4 O4 goes over to CaCO4 plus NH4.
Okay, that's pretty good. What was this?
NH4 O4.
That? Alright, let's go through and let's solve this out. That's not quite right either.
We ain't gonna read it.
We're gonna do it. Okay, so for this first one, you alright? This is calcium chloride. So this is the correct way of writing calcium chloride because you do okay. -1, calcium always be the +1. So this first one is perfect and correct. This one, you got slightly messed up on. Seems like both of you did, so that's okay. So I'm gonna know how to figure this out. So this one,
How do you figure out charges?
What?
How do you figure out the charges?
Go to
You
the
gotta
charge.
know them. Charge chart.
Where's
Gotta
that?
remember. Remember it's pH, I think 42. With your ions, you gotta know your ions. That's why I said you don't have to memorize them for the quiz, but you better memorize them for the test. Alright, so for this next one, calcium and ammonium carbonate. Alright, you got right, Ethan, this is carbonate, and you have the right idea this is ammonium. Alright, carbonate takes how many though? What's the charge of carbonate?
2.
2. So you have the right idea, but you can't stick 2 out in front because that means that there's 2 of everything in the substance. So instead of just sticking 2 in the front, what can I do?
Nothing.
and then that would fix it for you. That's another reason why you want to write your molecules correct the first time, and that's where you got stuck on. So you had the right idea, but it would have messed up all of your balanced equations with it. So yeah, so make sure, since this one only give up one at a time, but this one needs two, so there has to be two of them. Anyone have any questions about that one?
Nope.
Alright, you got this one exactly right for calcium carbonate, and then you got this one exactly right for the ammonium chloride. But now you just gotta balance them. Alright, so let's double check your balancing, cause there was that was the one thing that was off, so let's go back and let's check it, make sure. Alright.
Since I know how to do it now, can you do 2B and I'll work on 2C real quick?
Sure. Alright, Ethan, how many calcium you got on each side?
Per B?
Oh, we're still on A, because we gotta check to make sure that everything's balanced since I changed your molecule.
One
Right.
on the left side and one on the right side.
So it's already right. Alright, which one you want next? What substance?
CO3.
Alright, carbonate. Alright, how many on the reactant side?
One.
How many on the product side?
Two. One.
Good job, that was balanced. Alright, you want chlorine or do you want ammonium?
Ammonium.
Alright, how many ammoniums you got?
Two.
Alright, on the reactant side, how many on the product side?
Two.
Two. Good job, that was balanced. Alright, chloride, last one. How many chlorines you got on the reactant side?
Two.
How many on the product side?
Two.
Alright, so everything's balanced. So this was actually balanced as written. I just wanted to make sure
I
you
think it
know
was.
how to write them out. So
I
you
got that one
close.
right then.
What?
I got that one.
No, you said.
Oh wait, that one. Oh, that one was written. Okay, never mind.
Alright, so this one was right as, so this one was right, it was checking to make sure, can you write your ions? So that's the reason why.
It doesn't say the charge of sulfur on here.
Sulfur should be on the anion side in the 2 section.
I see silicate, sulfate, and sulfide.
So sulfite's not on there? Did you see sulfite?
I need sulfur.
Hey, bro, you okay?
Alright, so it's okay, it's a practice.
Oh, check it out.
Alright, it's also up here as well. Where's number 2? Sulfide, because remember, whenever you have sulfur, whenever you give it an anion name, that's the reason why. So don't just freak out about, okay, where's the exact same one? No, remember the names change whenever they're an ion.
Dioxide, oxide gives off 2, so dioxide means it'll give off 4. Or needs 4.
Say the whole thing. Which one are you on?
Sulfur dioxide. And 3, 2, 3, or 2C.
Sulfur dioxide. So this one is a non-metal to a non-metal, so they're going to have prefixes. So sulfur dioxide, how many oxides are there?
2.
There you go. So the SO2. Alright, so back to this one then. Alright, Ethan, what do you have for this one? Give me just your
For
answer.
B?
This is for B.
KCN plus HCI arrow
Okay, CL, but yes.
HCN plus KCl and yeah, I already have them.
That's it? That's it? That's all you got?
I had.
Alright, Chris, you got anything different for B? I gotta check to make sure that I'm not you got B right.
Do what?
B, did you get anything different for B?
I got PCM instead.
Okay, remember, potassium is K. Alright, so Ethan, is it already balanced as written? It is actually. Letter B is balanced as written because it's just making sure.
But you're
you
right,
figured it out. So good job. Alright, letter C for this one. Alright, Chris, are you happy with this one? Or
No.
Okay, ready? Alright, give me your answer. This one is written.
2H2S plus SO2 goes to 3S plus 2H2O.
Okay.
2H2O.
Alright, so 2H2S plus SO2 plus 3S.
That was balanced.
Make sure.
It is balanced.
Yeah, that is the correct answer for it. Good job. Alright, anyone have a question about how to solve these?
Why am I so good at that?
I got that right too.
Alright, so the last kind of math thing that we need to work on before we just go over just straight terms, you might remember percent composition from chapter 4. You need to practice with these. So, I'm going to slide it over. Jamie, I'm going to make it a little bit larger so that way so you can go ahead and read it as well. But anyone remember, how do you solve percent composition? Okay. What do you do? Alright, so remember, you're finding the percent of the substance. How much of the substance is a certain amount? So,
I think so. So,
if you look in your book, it's on page number, let me get over there. I have it on my post-it on chapter 5. It's on page number 45 is where it tells you how to do it.
Really?
Page 45, yep.
I wrote through my brother these.
Percent composition.
Present composition, how do I find it? What do I do?
What?
Yeah.
You find your molar mass of the compound.
Alright, well it already gives me what the mass is, so why do I need to find molar mass?
Then you need to find percent of total contributed by each element. So you like divide stuff and then multiply by 100.
Oh
Yeah,
so
alright,
that
I
was
think
so
that,
slick.
okay, hang on. Jamie, I think it shows up for you. I think it shows up on my screen, so I'm sorry if the blur is really bad. Email me if you need this emailed to you. Alright, but yeah, so what do I do?
So you already have the base weight. So what you want to do is you want to take 16 and it's already just drop the G and make it a percent. 16 grams. Just drop the G on it.
You're thinking of how to go from grams into the empirical formula. So for this one, I'm just figuring out what
I'm
is the
reading
percent
how to find the percent of the total contributed by each element.
So you're thinking of changing from grams to the step, but I'm thinking of the
Take
next
16
one.
and divide it by 18.
Why 16?
Because that's how many oxygen.
There you go, that's it. So you're taking for hydrogen, yeah, I have my books to it. So for this one, if the total weight of water is 18.0 grams, and you want to figure out what percent hydrogen is of it, or oxygen, we'll just start off with oxygen. Oxygen weighs 16.00, or 16.0. So you take 16, divided by 18, times 100, so that way it turns into a percent, and that gives you what?
Um, 88.8%. Or 88.9.
Okay, I was like, okay, you could be rounding, but yes, 88.9% for the 3-6 for this one, since I told you it's 18.0. So hydrogen
It's 11.3 or 11.2.
Yep, no, I know, no, keep in mind that yes, because of 6 grades, they're gonna be slightly off, but yes, that's the reason why for it.
How
So,
about I this real quick?
what?
Do it too quick.
My man over here like that old lady tapping on the phone.
Alright, so remember for this one, Ethan, you take the total weight and you divide it
I
into
got
the
it.
weight. Oh, you got it now? Alright, so try to solve the second one by yourself. So if sodium.
I'll do the answer.
Wait, don't yell out the answers. So try to figure it out yourself. I'll give you maybe a minute. So this is sodium chloride, so NaCl.
Oh, we're on the next one?
Yep, number 2.
Nice.
Okay, guys.
Okay, give Ethan another minute. Alright, Jamie and Quentin, I'm going to go ahead and switch down. If you need it, just pause it.
Cheesy cookie.
This is what you were thinking of for the other half of it. Alright, Ethan, do you have sodium at least yet? Don't worry about this, don't worry about it yet.
Oh.
Did you still need the top problem?
Yes. I was like, what happened?
Such a failure.
Okay.
Such a failure. Can I get the answer?
No.
Wait, we'll give Ethan another minute and then I'll check your answer. Be looking over how to solve the other half of this on the next page.
I have my answer.
Alright, you got your answer, Ethan?
Really?
Alright, what is the percent composition of sodium, Chris?
39.3.
Good job. Yeah, technically it's 84 because I gave it to you in 4 sig figs, but yes. So, since there's 4 sig figs, 4 sig figs, the answer has to be in 4 sig figs. But yes, you have the right answer. That's sodium. Alright, Ethan, what's chloride?
60.66%. 60.66%.
You sure it doesn't matter for 6, 7?
No, it doesn't have that at all.
Mine.
60.67%.
There you go. So say mine rounds up. So just double check your calculation work. Alright, so anyone have a question about how to solve that though? Take calculation for 6 phase. Alright, let's look on the next page. It gives you how to go if you're given percent composition. How do you go backwards then? Figure out the empirical formula. This is what you were thinking of, dropping the percent and converting to grams immediately. This is what you were thinking of for it. Now, if I start off, let's say I have a substance that for silver, it is 63.50% of the substance, what's the first thing that I do, Chris?
Divide by 100.
Not yet, because.
Oh, 60, with the 63.50, you
Yeah.
Multiply by.
You got the percent, and you automatically assume that there's 100, so wait, it turns into grams, and then what do I do?
take the 7.068.
Okay, so that's for sodium,
And
so
then,
same thing,
Yeah, and then times it by 100. You
Okay.
just assume, so you just drop it,
so
right?
you just drop it,
And then you multiply by 63.50.
you gotta multiply these two together?
Yes.
No. Alright, so 28.25% convert to grams. Alright, so this substance is made up of 63.5% silver, 7.068% nitrogen, and 28.25% grams. So you automatically assume that there's 100 of a substance, so it automatically drops the percent and it converts to grams. Alright, I need to know the mole amount. So how do I find moles if I'm given grams?
You look on your parent.
If you have to look on your periodic table, I will tell you what it is on the test if you need this. So silver weighs how much then according to the periodic table?
107.9.
107.9. So that'll give me how many moles of silver? Solve. How many moles of silver?
I thought I'm so slow when I calculator.
0.588506.
Good enough.
0.58.
I'm going to start at 5 sig figs.
878.
I'm going to start at 5 sig figs because since I started with 4 sig figs, I'm not going to need more than 4. Alright, so sodium weighs how much according to the periodic table?
Sodium weighs.
Alright, sorry, this is nitrogen.
Hold on, let me look.
Nitrogen.
It weighs
32.06.
Nitrogen.
20.
What?
Nitrogen 1 point. No, nitrogen.
Nitrogen.
14.01.
Good job. 14.0.
I can't even see, bro.
Alright, so divide, hurry. 7.068 divided by 14.01.
I'm going to the next one.
0.5044967888.
Good job. We'll stop.
Subma.
I messed up. Yeah, that's where that was messed up. So that's mole. Yep. Alright. Oxygen. How much does oxygen weigh according to the
It
table?
equals 1
Wait.
point.
How much does oxygen weigh?
16.00.
Oh, now what does it equal?
1.765625.
Let's keep it in turn. You already got 2. Okay. Ethan.
1.765625.
Okay, we'll stop with that. Alright,
Thank
so
you.
now that I know the moles, what do I do? What's the next step? I'm going
You
from.
take the smallest point, 7.068.
This is the smallest?
You take the
No,
smallest and
no.
then you divide by all.
I was looking at the wrong one.
Okay.
The smallest one is 504.
Good job.
50. And
So
you
you-
divide that by everything else.
Okay, so this one would be what
One.
then? Good. What will this one be?
1,
Okay, what will this one be? Now we
Two.
have to actually talk to you guys.
2.
What?
I'm guessing. It's
Three.
3. It's 3.
Alright, so if I'm writing out the empirical formula for the substance, what does that mean? How many silvers do I have?
1,
Alright, so silver 1. How many nitrogens do I have?
1,
How many oxygens do I have?
3.
Good job. That is the answer
Easy.
for this one. Alright, do we have any questions on how to solve that?
No.
Do number 2 then by yourself. I gotta check them out. Hurry, I'm almost out of time. I gotta go. Gotta over terms fast. There's not much time to the section.
Could have kept that up there.
Actually, no. We'll let you try to figure out the entire thing all by yourself.
I was going to do that, but okay.
This one takes it a step farther though.
What do you mean?
It's asking for molecular formula as well. So don't just stop once you have empirical formula and listen to what's the molecular formula.
Did we just do that?
We found an empirical formula, we didn't find molecular formula.
So,
Just a lot of math and a lot of application. Depending on what you're doing and what you're getting.
Oh, okay.
What is molecular formula?
Molecular formula? Alright, so how do I find molecular, what's the difference between empirical and molecular formula?
Empirical is the simplest ratio.
So if if you're stuck there for like 1 second, but Ethan, do you have the empirical formula yet?
I haven't heard of one.
I have it too.
Okay, good. What's the empirical formula?
Oh wait.
HO.
Good job. So
Oh, wait.
H's first. You do that H first. So you're right that it is a 1-to-1 ratio. So if you don't understand, Jamie or Quentin, how to do it, email me and I'll tell you how to do it. But yes, you're right. It is a 1-to-1 ratio by the time to solve everything. All right. So so it tells me something. The molar mass of this substance for real is 34.02, and it wants to know, okay, is the empirical the same as the molecular formula then?
Yeah.
All right. So what is the weight of HO?
34.02.
No. What's the weight of HO?
17.008.
Good job. Alright, so this is how much it really weighs. This is how much my empirical version weighs. So what do? I divide
Multiply.
the real weight by the 17.008. Don't tell me how many times I gotta double everything. Or triple, or quadruple, or whatever it is.
2.000235183.
Yeah, so that means if this one goes into this one 2 times, I need to double everything. So instead of just being HO, it's H2O2 or hydrogen peroxide. That is the real formula.
Okay, you divided 34 by, okay, gotcha.
Alright, anybody know how to solve that?
Nope.
I have 10 minutes, so we have no. Alright, so, but keep in mind, most of this chapter and the previous and the next chapter,
So there's not too many terms.
there's not a lot of terms. We covered pretty much everything we needed to know for it. So let's go over
So
terms
we
of
pretty much already reviewed everything.
Yeah, pretty much. We just gotta go over lots of bits and stuff.
Do we have homework today?
No. Alright, Ethan,
Thank
you got
the
your dice?
Lord Almighty.
Yes.
You got your dice ready? Alright, we're gonna rotate this. We'll start with Chris. Alright, went over how to name a binary molecule, how to name an ion, how to name the difference between empirical formula, molecular formula, chemical formula, stoichiometry yesterday. Note your cations and your anions on page 40. You need to go over that chart again and learn how much they are, learn them. Alright, what is the sum of all the atomic masses of all the atoms in the formula?
What's the
M. What's the sum
mass
of
number? Molecular mass.
molecular mass? Roll. What is Avogadro's number? Gotta know this.
6.22 times 10 to the 23rd.
Good job. What's the unit that represents Avogadro's number?
And
Which one?
5.
mole.
Mole. Avogadro's number. Alright, what is the mass
Two eighths in a
per
row.
what is the mass per mole of a substance? So
What?
What is the mass per mole of a substance? So if I'm going from grams to mole or moles to mass, what do we call that?
Let's start with
M. Mass per mole, so
mole per mass. Molar
it's
mass.
not molar mass, it's correct. Mole. Alright, what's the units for molecular mass?
Grams per mole? No, what's the
Molecular mass.
mass number? No, what's the
What's the units? Like, how do I measure it? Because I can't measure it in grams.
Grams.
It's too small.
oh,
Grams
is
too
it
small.
kilo? No, AMU.
AMU. Yep. What's the units for molar mass?
What's the unit?
What's the units?
No.
Alright,
Gram. What's the
grams. But they're
Gram mole.
grams and kilograms? Grams per mole.
grams per mole is the greatest. So that's the only difference between those two. The processes are exact same, you add them up, but it's grams per mole. I'm gonna just check over. Alright, so it's Ethan's turn technically now since you're still. We've gone over, that's basically all chapter 4's turns. Chapter 3's turns. Chapter 4's turns. What is a symbolic representation of a chemical reaction?
A chemical formula. Chemical reaction. What's the second word, so?
E.
Chemical equation.
There you go, chemical equation. What do you call the stuff on the right of the chemical equation?
Product.
What's the stuff on the left?
Reactant.
Good job.
Four.
Alright,
I can have two goals?
what?
You said I can have two goals?
No.
How about say, whoa.
If you know one or the other. What's the law that says that the sum of the masses on the reactants has to equal sum of the masses on the product?
Law of composition of mass.
What was it?
Law of composition of mass.
Yes, just remember, reactants are on the right, products on the left, they have to equal the same amount. Alright, what does the arrow mean in an equation?
What's the chemical reaction? Is it reactant?
Nice.
Reacts with?
Close enough, so yields or produces. Close enough.
Nice.
Alright,
Nice
alright, what type of chemical equation is it? Remember, there are the four types for two substances coming together to make a new substance. What type of chemical reaction is that?
Let's start with combination.
Yeah, combination or synthesis is another name for it. So combination. What do you have? You have one substance that's breaking apart.
Single. No, wait, it would break it apart. You have the composition.
Decomposition. What do you have it whenever you have one substance and a compound, and that one substance takes the spot and kicks off one part of the compound?
Let's start with.
It starts with a S. If you have, I think you get to see this. This will not be balanced, but I'm just going to ignore it. So what type of reaction is this?
Single displacement.
Single displacement.
Oh, okay.
Double displacement.
I didn't even ask, okay, what is double displacement then? Did you
Double
give a term?
displacement is when you have two different things on the reactant side, and then two things get left out by themselves.
So I'm gonna have to write it over here. So if you something like this. Ooh, we're gonna make a basic one. We're gonna do this. Probably wouldn't happen this way, but that's okay. So
Life.
yeah, that's it. So
Life.
what would happen over here then?
What is
you
life?
have FCl, and then on the other one you have Li in it. If you want to do another word.
Oh, alright.
That wouldn't never work, but I'm just saying, like, just as an example.
Alright, there. Couple things. Alright, so you're right that they swap partners. But over here, sodium and lithium, they want to gain electrons and lose electrons. Lose. So they're positive one.
I wasn't trying to make
I know, but it's the idea of this is A, B,
Yeah.
C, D, that the anions and the cations will never, ever go together. So for this one, it would be NaF plus lithium, chlorine. I know what you were thinking of, but yes, so you wouldn't ever see it put that way though. It would bother me. Okay, alright. So, you have a question about it? Okay, just make sure. Cations and cations, they can go together, and anions and anions can go together. What?
I got it right.
You did. Go.
I already did.
Alright. What do you call the reactant that you're gonna run out of first that determines the amount of product that is formed?
Say it again, and what is start?
What do you call the reactant that determines the amount of product that can be formed because you're gonna run out of it first? Just an L.
I don't know.
Limited reaction.
Oh,
Those limiting reactions was well.
Oh,
Alright.
another 8.
I believe that's all the terms actually.
Yeah, I got 58.
40.
Make sure, if not, we'll just have to down some more because you have that on your desk. Yeah, that's pretty much all the terms.
Okay, that one.
Nice.
Alright, do you have any questions though about the terms between like empirical formula and molecular formula? Alright, well I still have 5 minutes, so let's go ahead and let's practice then on page 59, 2D. So this is a good way to practice with your ions and balancing. Ions and balancing. Let's see if you can do it quickly. So try to solve it as best you can and then I'll catch up. So 2D. Hexane, did I get you to? A liquid burns in the air, oxygen, to form a gas is carbon dioxide and water.
Page 59.
59, 2D. So you're back to balancing again. I'll go ahead and turn off that sound.
Carbon dioxide is CO, right?
Carbon dioxide.
C2O? O2?
CO2, you are correct. sure what you do.
Is that right?
You sure? Alright, alright, Ethan, how close are you to being done? Good job, that's good. Try to do E then by yourself.
Trying to do what?
E. Alright, Ethan, it's been about a minute. What you got so far?
Is that nitrate? Is that N3?
3 CO.
Wait, I can't listen. I can't listen to you. So you're on E for number 2?
Yeah. What is nitrate? NO4?
You go back on it.
Oh, the number 3. Okay. So for this one, Ethan. Alright, you have this so far written down?
Yes.
Alright. So which one do you want to balance first?
Page 14.
Alright. So how many do I have on the reactant side?
14.
Which one?
14.
How many on the product side?
2.
How do I fix it?
47.
Alright, so how many do I have total now?
14.
Alright, hydrogen's done. Which one do you want to do next?
Carbon.
Alright, how many do I have on the reactant side?
6.
How many on the product side?
1.
How do I fix it?
36.
Alright. Oxygen, good luck. How many oxygens do I have on the reactant side?
2.
How many do I have on the product side?
12 plus 7 is 19.
Alright. So, can 2 go into 19?
No.
What's the trick?
Double everything.
Alright, so what does this become then?
2.
Alright, we'll ignore this one for right now because we'll come back to it. Alright, what does this become?
2.
It was,
What was that?
it was 6.
12.
What does this become?
14.
What was it?
14.
14. Alright, so let's go back and let's double check everything to make sure we didn't accidentally mess up anything. Alright, so back over to hydrogen again. How many hydrogens do I have?
28.
How many on that side?
28.
Yay, you sound so excited. How many carbons do I have?
12.
How many on the other side?
24. 12.
Okay, 12. Alright, how many oxygens do I have right now for the reactants?
2.
Okay, we'll worry about that one. Alright, so 2 times 12
24.
plus
14.
equals.
38.
Good job. Alright, can 2 go into 38?
Yes.
Alright, 2 goes into 38. How many times? You have a calculator?
19.
So, whoops. Yeah. Alright, so is it balanced now? Yep, that's it. So, just double everything if you get stuck. I'm gonna help you out for it. Alright. Chris, were you able to finish yours?
I'm close.
Okay. Well, the bell's about to ring, so I can't start that one. But just make sure you're studying. Alright, so what's the name of for the molecule that shows how many of an atom there actually are? What do you call that type of formula?
Chemical formula.
Okay, well, what type is it specifically now if it shows the
Empirical. Molecular formula.
molecular? What if it shows the smallest ratio?
Empirical.
Empirical. What's another name for the empirical formula? Talk about ions.